Okay, so this is a gearbox with a 14 teeth sprocket installed, and we will replace that one with the 15 teeth sprocket. So this one, the diameter is not too large, which you can see in some sprockets from Thailand. So it is not really a struggle to get that one in. This one is exactly made to fit with a large sprocket. So this one makes it possible. Many other sprockets, wow, it's really hard to get them in. So that's what we will do now. It's really balancing on what is possible. Right, so here you can see we drop in. And it's as easy as this. I mean, it's no struggle at all. Easy. See? It's really not with a hammer or anything like that. I've seen everything on YouTube already about, well, how not to do it. So we worked this one out. The diameter of this one is perfect to work in combination with a big sprocket. So you get your 15 teeth, you get your higher top speed, and you don't need to touch your ECU. And that's what most people want to see. Yeah, just drop it in, pull the bolts back on, and that's basically it. You're good to go. Okay, let's finish this job and let's make a test run. See how it goes. I forgot to point out, so we make the gear heavier and we drop the weights from 11 gram to 10 grams to allow the engine to pull the heavier gear in an easier way. So to not make it too heavy to pull the gear, the new gear sprocket. So we go 1 gram lighter on the roller weights, and we will do the test so with 10 grams and not with the 11 grams which we used before. So 10 gram roller weights and 15 teeth sprocket. Well, yes, this road test is actually not really a road test, because as you saw that as soon as we throw in the other camshaft, the temperature was rising compared to the formal camshaft. Now, with throwing in the 15 teeth sprocket, you see we are here at 130 degrees, and I had to back off the TPS throttle position. I had to lose the throttle because it's overheating. It's way too hot. And well, we can't do really a speed test with that. So we need to work something out to get rid of the heat. So we will install now the larger valve cylinder head on our 62 bore. Okay guys, we are here now at Bike, his shop, and we will take a look with the burette how much the volume is from the GT4 R head, the new head. And yeah, let's check it out. And we have worked also another camshaft out because we think it will be a good thing to have some more degrees on the exhaust to open it longer, and the intake as well, actually, to keep it longer open, to have a better ventilation inside the head to benefit the cooling. And we know while we are doing this that the dynamic compression will drop. So we check now with the burette how much the volume is from the head exactly, and we can work the piston out accordingly. Yeah, so Bike put some grease on it so the valves would not leak at all. And this without valve springs installed. So that's the idea basically. If there were valve springs installed, well, then no worries, of course, it won't leak. Institute Hawk 10.6 cc. 10.6 cc. Okay, so we know that. 10.6 cc for the silent head. Bike decided that he wanted to do a second test to see if we end up with the same result. 10.6, well, let's see.
Hello.
Minkan? Okay. 10.6 cc. Same result. So we can be sure about that. Okay, next. So okay, because we have slightly a dome now from 1 mm, we need to push the piston a little bit deeper in the bore to check the volume of the water, and then later on we can calculate how much exactly the dome will be and how much the compression ratio will be. So we will do that now. We will calculate the volume and then deduct the dome volume of what we have as result. That look okay, yeah. 5.7. Hard should get 5.7 cc. So that's now with the new piston in the bore for the new cylinder head. So a little bit more compression, but nothing crazy to make it reliable. So okay, let's put it together. Well, we will do this off camera and we will come back once that is done. Guys, so we are still at the bike shop and we will install now the new GT4R cylinder head on the engine. And what I want to point out, guys, is that we modified the exhaust port. It's a big port, and we made it possible to install a large exhaust gasket, and also to install the stage 3 exhaust from Uminashi, which is especially made for this cylinder head, guys. So you can run the 63, also 64, 65, 66 should be okay. So this is the header, and you can see this is the copper gasket with the large port to install the 28mm inner diameter exhaust. So this is something I want to point out, guys, that is important. Yeah, so big exhaust, don't install the small one. The port is 28mm and this exhaust match the exhaust port. So this exhaust port is 28mm and this one is matching perfectly with the port. So okay, guys, you can see it over here. This is the I don't know if you can see it, it's dark already, right? But this is the stage 3 exhaust, and that's the big one. So that's with the inner diameter of 28 millimeter. The outer diameter of the pipe is 32 millimeter. So yeah, keep that in mind, guys. If you install the cylinder head, you need to have the big exhaust. The higher degree camshaft we have worked out, guys, a little bit more lift. This will drop the compression, so we will push the compression up a little bit with the dome, a little bit dome in the piston, and the camshaft with the degrees, the dynamic compression will go down. So that's the new camshaft, and let's see how it goes, if the performance is good, and if it will drop the temperature, because that's the main thing now, to get control of the temperature. So let's see how that goes, and we get back to you. So I think interesting to point out, guys, that the new camshaft has been designed in combination with this specific cylinder head, and it doesn't touch. It has a high lift and it doesn't touch, but barely. So we have nothing left, or it would touch, but it fits perfectly. So no worries, guys, you can install this camshaft with this type of cylinder head. And we also worked out some other valve springs. So we are not using the original valve springs, which you can see over here. They are longer. The wire thickness is the same. It's 1.8 millimeter wire thickness, so that's the same, but they are slightly longer. We also have other valves prepared for the higher lift, and these valve springs work with the high lift valves. So everything is prepared to run a higher lift, basically. So that's what's going on. So what we are doing with the piston, we bump up the compression, and we lower the compression basically in a dynamic way with the lift and with the degrees. So if you take longer degrees camshafts, then this will lower your dynamic compression. The aluminium in this cylinder head is machined in such a way, I should say, that you can run high lift camshafts. If you have another 4-valve head, they sell different styles of heads, different brands of heads. We're not sure that you can run our camshaft in that head, because as I said, our head has been built for that specific camshaft to be able to run it. So keep that in mind, guys. Yeah, and these valves are stronger too. Even if the wire thickness is the same, the valve height is longer than the stock ones, as you saw. So the preload on the valves will be more compared to the stock valves. So here you can see, guys, that we can adjust our valve clearance without a problem. But if you have a cylinder head which isn't intended to be installed, or isn't created, built, how should I say it, for a high lift valve, then you will not be able to install a feeler gauge in between your valve and your top it adjusting, how you call that, bolt. So it will not be possible. The cylinder head need to be prepared for the high lift camshaft. So I want to stress this, guys, because we will produce this camshaft, and well, if you don't buy our cylinder head, then there is a big chance that you won't be able to install it. Not our fault, guys. I just want to stress this. The cylinder head must be built, created for the high lift camshaft. Otherwise, not possible. So here you see, no problem. We can adjust the valves, no problem. We are bumping up the compression ratio, and we recommend to use some high temperature silicone gasket. As you can see, guys, it's not a lot which you need to use. It's just slightly and dipping it around. Very important is that you don't lock up the coolant circulation holes. That's not the idea. So tap it around slightly, so it makes a perfect seal on your gasket. Because as I said, we are bumping up the compression ratio with this is a new piston we are working out. So we will run with this piston on the new head, 20mm head with high lift camshaft. So yeah, so every cylinder kit you buy from us comes with high temperature silicone gasket in the set. Yeah, we will finishing this one up and close the engine. So yeah, we are torquing the bolts now, setting everything to torque the bolts, finishing this engine up, install it in the bike. Okay guys, so you saw yesterday that we tried to start the engine with the engine not installed in the body. Meanwhile, we installed the engine back in the body, and the reason why the engine didn't start was a bad spark plug, weird enough. So it happens sometime if you are using a new spark plug like we did before, and you throw a lot of fuel to it, that well, the plug goes bad on you. So that's what's happened basically. So now we installed a new spark plug today. We're closing everything up. So let's see how it goes. Okay, so first time we start the bike up. You also can see that we have the large header exhaust installed now. And that's with the inside or inner diameter, as they call it, of 28mm, which is 32mm on the outside. So that's what's going on over here. Right. So we will replace it now with the Uminashi radiator, which we have over here. And this is the large radiator as well, but it has a metal cap on it that you don't need to close with a tool, but by hand, firmly. And this is the 1.6 bar pressure cap. Yeah, here you can see the 1.6 bar cap installed, metal one, not plastic one, and the white radiator. So yeah, we will replace that now by this and see how everything goes. So this radiator have a much larger coolant capacity as the stock one as well. Means there is more coolant in circulation, which helps the cooling capacity, of course. And this one is a metal cap, not a plastic cap. 1.6 bar and not 0.9 bar. Okay, closing everything up and start it up, see if there is air in the circulation or not. Okay, let's see. Okay, we install the 9 gram roller weights and let's see how it performs with the 15 teeth sprocket installed. So the top speed, or the possible top speed, is good, much better than the 14 teeth sprocket. Only in the, how can I say it, area around 115 km/h or something, it's not good. It's worse than with the 14 teeth sprocket, which was expected to be, because the 14 teeth sprocket make it much easier to accelerate. The 15 teeth sprocket makes it much heavier to gain top speed. It makes it much heavier to run the engine, and so therefore, yeah, we will lower the weights now. So I will do it in 2 ways. Okay. 3, 2, 1. And here we go again. Yeah, and we will do it in 2 ways because this direction is the slightly uphill direction, and while the other side, of course, is then the downhill. And this gives a totally different result with 10 grams and 9 grams. Because the 9 grams makes it much easier to deal with the load with headwind, with an uphill, compared to 10 grams. And you start to see that over here actually. So when it's going uphill, the 9 grams will have a much easier time to work, to deal with that, compared to the 10 grams. So in this test here, the 15 teeth sprocket installed on the stock 44 teeth sprocket, and yeah, you see that this also have an effect on the AFR, on the air-fuel ratio. The lighter weights are running a bit leaner compared to the 10 grams who are running a bit richer, and that means it's more struggling. So temperature, that was the main thing, seems to be solved. So that issue is no longer existence. That's sorted, no problem anymore whatsoever. Both are holding 93 degrees Celsius, so that's perfect. Clearly again you see the difference in air-fuel ratio. While it's the same 170cc injector installed. 11.2 on the 9 gram roller weights and 11 on the 10 gram roller weights. Keep in mind guys that the AFR you see here is based on the narrow band sensor from the ECU Connect we are using and not on a wide band, so this is not the real air-fuel ratio as you would see with a wideband sensor, but this gives an indication about the difference, and you still can use it to compare it with each other. That's no problem whatsoever. So in this test you see that the 9 grams are doing much better compared to the 10 grams. And well, here we go, 129, 130 compared to 122 at the moment. So yeah, let's see how things go in the other direction. So let's move over to the other side. Okay, this is the way back. 3, 2, 1. Yeah, so this is the test on the way back in the other direction, and the first test was uphill, so this makes this test the downhill section, which will do great with 10 grams, of course, because we saw that at the other side of the motorway that the 9 grams were doing really great uphill. And now the 10 grams will do great because the variator will be closing in harder. 10 grams are pushing much harder on the variator to close them. The belt will rise more easy higher, and you will gain a higher top speed because the engine has the power for it. So usually the engine don't have the power for it, but if you have tailwind, if you have a downhill, and if you have roller weights who are pushing hard, then well, you can really make a fast top speed. The trick is to find the right balance between the first test where the 9 grams did better and the 10 grams which result better in not so much load. Here you see 127, 128, and it will go up and up and up because yeah, no problem, the grams are pushing, and the engine don't need to see AFR as well. The engine get away with it. So what you need to work out is basically something that will have an average of working properly all the time. If you open the throttle, wherever you are, whatever the wind will be facing towards you or tailwind, if you open the throttle, you want the bike to move. So basically you need to work something out between the 10 grams and the 9 grams. So it could be a good idea to reduce the 1544 gear ratio to come down a little bit, to make it easier to pull this sprocket ratio and to run better all the time. At this moment actually we're working a special torque spring out with a bearing installed, and you will see in the next video we did test with that this provides a good result. So that's basically what we have at the moment, and see you in the next video. Thank you for watching.
And take a look to the Yamanashi website. We are ready to deliver all parts you need worldwide to your doorstep.